Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustasin, your teacher for CSC 322 Operating Systems Concept. This is lecture number 2. We are still in studying the chapter number 1 of Modern Operating System by Andrew S. Tenenbaum, and I've already recommended you the 3rd edition of this book. Okay. The last lecture we concluded the lecture up to the 3rd generation, and today I will start with the 4th generation. And as I have already explained that though it's a bit old, 1980 and till to date, but we have still kept everything that has been invented and introduced during this era as considered as the 4th generation. Although very recent development has taken place in the form of tablets and mobile phones, but yet we have not given it the name of the 5th generation. So 4th generation basically based upon large-scale integrated circuits, LSI. So large-scale integration, we call it as a wafer also, a chip which has thousands of transistors on a square centimeter, that produced PC initially, and concept by the Moore. I don't remember the complete name, it's given in the book as the one of the founder of this computer system, the current manufacturer also. He says that after every 18 months the number of transistors per square centimeter doubles, and his theory is true for the last 3 decades, and it is expected that the next 10 years his theory will still be true. So we have got more and more transistors that has resulted in the advancement of the computers. This LSI has introduced the microcomputers. They are just like the mini computers. I didn't touch about the mini computers. We talked about the mainframe computers, but after that there came the mini computers also. The price of the computer is much less. When we say that the mainframe and the mini computer could only be afforded by the big companies, but these personal computer, the price has gone such a low that even an individual can afford it, and nowadays every individual or most of the individual have its personal computer. In 1974, Intel introduced 8080 chip. It's an 8-bit CPU which needed the operating system. Intel asked Gary Kildall to write one operating system for their personal computer. Kildall first built the interface floppy. It was a larger size floppy. We call it as 8-inch floppy diskette. He linked this floppy disk with the 8080 based computer system, and this is the first time that the disk-based operating system were invented, and he gave it a name as CP/M. CP/M. It's a control program for microcomputers. Then the Kernel formed a company, named it as a Digital Research, and started selling out its CP/M. 1977, Digital Research reproduced CP/M for Zilog Z80 based chip computers, and he was everywhere during the 5 years era. 1980, IBM introduced a PC and asked Bill Gates to license his basic interpreter and propose an OS to run on the PC. Gates obviously proposed and recommended that Digital Research CP/M is already available in the market and you can use that. So the IBM tried to contact Digital Research Corporation, but this was the time that the Digital Research Corporation, rather Kernel, make the blender, a big blender, that the mistake which was cached by the gate. He did not respond to the IBM with a license for IBM machines. So the IBM then requested Bill Gates to provide an operating system for their IBM-based machines. Bill Gates formed a company, named it Microsoft, and purchased already available software for personal computer and attempt by a local vendor, and called it as DOS, disk operating system. So Bill Gates procured that at 50,000 US dollars, I guess, and then he set up a team that introduced some advanced features in it and renamed it as a Microsoft Disk Operating System, MS-DOS. And since then, Microsoft and Bill Gates has never looked back, and they are the success story of the century. So the Microsoft used 80386 and 80486 initial version of very primitive and the version, but later they produced the a version of the operating system which had the feature of the operating system like Unix. So the CPM, MS-DOS and other OS were all command-based. In 1960, Stanford Research Institute invented GUI. Steve Jobs, the co-inventor of Apple computers, first introduced a GUI-based, very expensive version which is called Visa, and which failed commercially because it was very expensive. So he reintroduced a cheaper version and user-friendly version as an Apple Macintosh, with Apple Macintosh, which had a huge success. So Microsoft quickly looked into that, and Microsoft also produced a graphical user interface based OS, that is Windows 3.1, which had under it DOS operating system, and over that it was Windows 3.1. That was a shell then rather than the OS over it. Then from 1985 to 1993, this Windows 3.1 was almost on every machine of IBM and the personal computer, and was very popular. Then later on in 1995, Microsoft introduced Windows 95. That incorporated many OS, and it used MS-DOS just to boot the machine and run the old compatible programs on it. And it was a huge success of the Microsoft that forced Microsoft to introduce Windows 98, and that was a 16-bit based upon the Intel assembly language, developed in Intel assembly language, and it had the backward compatibility with the versions of the software developed in Windows 95. Then the next version of Microsoft that was introduced was not given the name traditionally 95-98, rather they gave it a name of Windows NT. NT stands for New Technology, and it again has a backward compatibility with Windows 95, but it was a true 32-bit operating system. Since one of the team member had an experience of using VMS, so some VMS features were also incorporated into this Windows NT. Windows NT was again not much successful in the beginning, but Windows NT 4.0 had really some breakthrough, and corporation started accepting it because it has some network features in it and had some basic facilities. So the next version of Windows NT 5.0 was not named as 5.0. It was given a name of Windows 2000. Once again, Microsoft has changed from the name to the year in which they introduced that. So Microsoft introduced another version simultaneously in the parallel with Windows 2000. They introduced Windows 98, a new version called it as Windows Millennium, Windows ME. Windows ME was again there in the public for very little time, and then came the competition, and few Unix versions were also introduced and were produced for the personal computers, and they got quickly the speciality on the strongest on workstations and high-end computers, and the different versions of Unix were also openly available for the personal computers. So the Windows system also support X Windows system. Initial version of the Windows were all usually the command based and very popular among the computer professionals. But X Windows system produced at MIT, it was a complete GUI. So they name it as Motif, which is was available and that run over X Windows system. So the Unix had got a new look, just like Macintosh and Microsoft, and they also in the run or in the competition produced this graphical user interface. Now this is the good time to talk about the hardware, because in order to understand the operating system, we need to review the hardware also. A very primitive, a very abstract model of the hardware could be this figure that you can see it on the slide, where all the devices like a CPU, memory, I/O devices, all are attached together with the help of a single bus, and this bus was called the system bus. So this is the most simplified version, and that's why I call it as an abstraction version of the computer system. And most advanced versions are also available, and I will show you one of the architect or one of the block diagram where you will find out most modern buses that have been invented and that have been are being used in the computer systems. So to work, it must know operating system should have a very good and clear-cut understanding, as we have talked about in the last lecture also, regarding the functionality and operation and working of the hardware, such as the CPU, the memory, the I/O devices. These all which are connected together, how do they work together, how the operating system will be installed over and above such that they can make a good use of these resources, and operating system should carry out its task, which is number one, providing the computer as an extended machine and an abstraction version, simplified version to the user, and another functionality of the operating system is to manage these devices and manage these resources. So let's talk about these devices along with their abstractions, means how these devices are looked at by the operating system, or rather the devices with this spectacle of the operating system. ठीक है, ऑपरेटिंग सिस्टम की आंख से हम इन डिवाइसेस को देखते हैं, so that we could have a better understanding that how does the operating system carry out its task. So the main device, the brain of the computer, is the central processing unit. The central processing unit execute the instruction, obey the instructions, follow the instructions given by the end user or assigned by the operating system to execute. What does it mean? Basically, there are three steps: fetch an instruction, decode an instruction, execute an instruction. In some books and some slides you might find out there is another step which is called save the result. But obviously when we execute the instruction, so we need to save the result. So we need to save the output of the instruction. Since we have to provide the input also, so we don't talk about the input and the output, we just talk about fetch, decode and execute. Fetch means to read the instructions from the memory into the CPU. This is called fetching an instruction. Decode an instruction. Decode means to interpret the instructions, means opcode and operands. This combination of opcode and operand is called a mnemonic. Spelling जो है mnemonics के are slightly different, so be careful. So decoding means to find out the meaning, what to do and how to do that. And for that purpose, you have to find out the operation code, the instruction itself, as well as the operands which are associated with that instruction. And finally, the execute the instruction. As per instruction means के जो काम करने को कहा गया है, उसको actually perform भी करना है. पहले fetch, फिर decode, instruction को receive करना, instruction को समझना, decode करना और फिर उसको execute करना. Every computer system or every CPU or every processor has got its own instruction set. What does it mean? कि Pentium has got its own instruction set which is different from the Spark processor. यानी कि हर प्रोसेसर का एक अपना instruction set होता है which is a unique instruction set. Decode की बात जब हमने की तो थोड़ा सा come back it again. So mnemonics means opcode and operands. Opcode means instruction itself. There could be different types of instruction. There could be the set of instruction that tells the system to read the data from the memory or to transfer the data from one point to the other point. Or it could be the instructions means to perform certain operations on operands. What are the operands? Operands are basically the parameters, the input parameters, the temporary variables or the input data provided to the instruction. So you can have the instruction, for example, add AX, BX. Add is an opcode that instruct के add करें contents को किसके AX and BX, which are two operands, and the result is again placed somewhere that we should know that we add AX, BX, for example, put the result in AX. So then there could be increment CX, so single operand instruction that says that whatever the contents of CX are there, it should be incremented by 1. So there are different categories of the instructions which are available in the instruction set. Then we have got the registers. Registers are the storage within the CPU. Storage within the CPU, it means that the registers are produced with the same material as that of the CPU. इसका मतलब है कि they are as fast as CPU. But since they are the part of the CPU, that's why they are very limited and they are very small in size. So we have got a variety of registers in the, for example, Intel environment. We have got the general purpose registers. For example, AX, BX, CX and DX are the general purpose registers. Then we have the source index, destination index are the two registers that provide you the indexing and addressing of the data into the memory. Then there are some special purpose registers, for example, program counter, stack pointer, program status word. These are special registers. Program counter, or in some other environment, it might be having a different name, but basically the program counter is a register that contains the एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन टू बी एग्जीक्यूटेड, यानी कि जो इंस्ट्रक्शन अभी एग्जीक्यूट हो रही है उसके बाद जो नेक्स्ट इंस्ट्रक्शन एग्जीक्यूट होनी है उसका एड्रेस जो है इज अवेलेबल इन ए रजिस्टर विच इज कॉल्ड प्रोग्राम काउंटर. सिमिलरली stack pointer that holds a procedure stack frame. What does it mean? It contains all the temporary variables, all the associated data which is required by a current procedure which is to be executed. So whenever you are required to save an environment of one particular procedure, you are required to save each and every associated data, means the registers data as well as the temporary variables data as well as some other associated data in the form of one particular frame, and that frame is identified by a pointer called it as a stack pointer. Stack is a data structure and that point out to the last item that has been entered into the structure. Usually it contains the last address and then it is decremented after taking the data out, but that you will study in some other course of the data structure. Then there is another very special register which is called program status words. That contains the condition code bits. Each and every bit of the program status word carries certain meanings. It could be the instructions or it could be the status bits, it could be the bit that change the user mode to the kernel mode, or it could be the resultant bits that gives you the result of the previous comparison instructions. So there are few instructions that you can set and reset. For example, set interrupt, or you can set few more instructions, but you cannot set the instruction to enter into the kernel mode. For example, अगर आप ये समझते हैं कि आप वो कर्नल मोड की इंस्ट्रक्शन को सेट कर देंगे और फिर आप कर्नल मोड में एंटर हो जाएंगे, it is not allowed. It's automatically set by the operating system. So basically, PSW contains the status, and with the help of those status bits, the user find out what has happened and what are the result of the instruction previously executed by the CPU. CPU basically is looked as an abstraction of the operating system as a time multiplexing. We have already talked about it in the last lecture also. Means that CPU is allocated, one time slot of the CPU is allocated to one user. After the expiry of that particular time slot, total environment of that procedure or that process is saved somewhere in the storage, and the CPU is allocated to some other process or some other task or some other user. So what does it mean? It means that at any particular time when the CPU is reallocated to the task which was previously blocked, यानी कि जिसको आपने ब्लॉक करके सीपीयू किसी दूसरे प्रोसेस को दे दिया था, कभी ना कभी तो उसकी बारी दोबारा आएगी. जब उसकी बारी दोबारा आएगी तो फिर क्या करना होगा कि वो तमाम एनवायरनमेंट जिसको सेव किया था उसको रीस्टोर करके देना होगा. इसका मतलब ये हुआ कि जिस पॉइंट के ऊपर वो प्रोग्राम स्टॉप हुआ था उस पॉइंट से ऑनवर्ड वो एग्जीक्यूट होगा. जैसे मैंने आपको बताया कि प्रोग्राम काउंटर पॉइंट आउट द नेक्स्ट इंस्ट्रक्शन टू बी एग्जीक्यूटेड. सो सपोज अगर किसी एक प्रोग्राम को पर्टिकुलर टाइम पर आपने उसका टाइम स्लॉट खत्म हो गया, आपने उसको ब्लॉक कर दिया, तो उसका प्रोग्राम काउंटर सेव हो जाएगा. That contain the address of the next instruction to be executed. जब उस प्रोग्राम की दोबारा बारी आएगी तो उस इंस्ट्रक्शन पे, जिस इंस्ट्रक्शन पे वो ब्लॉक हुआ था, यानी कि नेक्स्ट इंस्ट्रक्शन के ऊपर, वहीं से वो अपनी एग्जीक्यूशन, ना सिर्फ ये कि एग्जीक्यूशन वहां से स्टार्ट करेगा, बल्कि वो तमाम एनवायरनमेंट विच एवर was available to that particular program will be restored and programmed. So it is a transparent. यूजर को नहीं पता कि उसके कब उसके प्रोग्राम को कॉन्टेक्स्ट स्विच किया गया था, कब उसके प्रोसेस को ब्लॉक करके किसी दूसरे को सीपीयू दिया गया था और कब उसको वापस दोबारा सीपीयू मिला. Okay, so everything is user transparent, is done automatically, and it is done so fast, so quickly that hardly an interactive user realizes that. हर इंटरैक्टिव यूजर ये समझता है कि सीपीयू सिर्फ उसी अकेले को सर्विस दे रहा है, जबकि वो एक वक्त में हंड्रेड्स ऑफ यूजर्स को सर्विस दे सकता है, इसके अंदर सलाहियत मौजूद है। सो एक एब्स्ट्रैक्शन ये है कि वन टास्क एट अ टाइम सिंपलेस्ट काम है जो कि ऑपरेटिंग सिस्टम को करना है, दैट इज द वन ऑफ द एब्स्ट्रैक्शन बिकॉज ऑफ द हार्डवेयर, द आर्किटेक्ट ऑफ द प्रोसेसर, एंड देयर इज अनदर फीचर means ke there are certain processes which support pipeline processing. What does it mean? It's mean that they have a separate fetch, decode and execute units. What does it mean? इसका मतलब ये हुआ कि फर्स्ट वाले में there was just one single unit. जब वो fetch कर रहा होता है तो decode नहीं कर रहा होता है, जब वो decode कर रहा होता है तो fetch या execute नहीं कर रहा होता है, जब execute कर रहा होता है तो fetch और decode नहीं कर रहा होता है, because that was one single unit, one single CPU with one functional unit. But if a CPU have a three functional unit, one is called a fetch, one is called a decode and one is called execute. इसका मतलब ये हुआ कि अगर थ्री फंक्शनल यूनिट्स हैं एंड इफ एन इंस्ट्रक्शन एन इज बीइंग एग्जीक्यूटेड बाय एग्जीक्यूशन यूनिट इन द सेम टाइम, उसी क्लॉक साइकिल में जो डिकोडिंग यूनिट है उससे नेक्स्ट आने वाली इंस्ट्रक्शन विच इज n+1 उसको डिकोड कर रहा होगा, एंड इन द सेम मशीन साइकिल उससे जो पिछला फंक्शनल यूनिट है वो n+2 इंस्ट्रक्शन को फेच कर रहा होगा, यानी कि n इंस्ट्रक्शन एग्जीक्यूट हो रही है, उससे नेक्स्ट अगले साइकिल में एग्जीक्यूट होने वाली इंस्ट्रक्शन डिकोड हो रही है और उससे अगले साइकिल में एग्जीक्यूट होने वाली इंस्ट्रक्शन फेच हो रही है। अगले स्टेप में क्या होगा, जिसकी डिकोडिंग हुई है वो एग्जीक्यूट हो जाएगा और जिसकी जो फेच हुई है वो डिकोड हो रहा होगा और एक नई इंस्ट्रक्शन फेच हो रही होगी। सो वन इंस्ट्रक्शन पुश द नेक्स्ट इंस्ट्रक्शन फॉरवर्ड। इसमें सबसे बड़ी बात जो इंपॉर्टेंट चीज है कि एवरी इंस्ट्रक्शन विच हैज वंस गॉट इनटू द पाइपलाइन इज एग्जीक्यूटेड वट एवर द केस में बी। चाहे ऐसी सिचुएशन क्यों ना हो कि एक सीपीयू ने इंस्ट्रक्शन को एग्जीक्यूट किया, जंप इंस्ट्रक्शन फॉर एग्जाम्पल ब्रांच इंस्ट्रक्शन की गो टू सम अदर इंस्ट्रक्शन, इसका मतलब ये हुआ कि नेक्स्ट दो इंस्ट्रक्शंस आपकी एग्जीक्यूट नहीं होनी, बट सिंस द इंस्ट्रक्शंस आर विद इन द पाइपलाइन दे विल एग्जीक्यूट, बट इट इज द रिस्पॉन्सिबिलिटी ऑफ द ऑपरेटिंग सिस्टम टू एंश्योर द प्रॉपर एग्जीक्यूशन ऑफ द इंस्ट्रक्शंस, यानी कि अगली दो इंस्ट्रक्शन को डिस्कार्ड करने की जिम्मेदारी भी ऑपरेटिंग सिस्टम की होगी। Okay, our operating system will provide the environment as if the program is executing sequentially. The instructions are being executed sequentially. जैसा कि फर्स्ट में मैंने आपको एक्सप्लेन किया कि एक वक्त में एक ही इंस्ट्रक्शन जाएगी और 3 स्टेप परफॉर्म करेगी, और सेकंड केस में पाइपलाइन प्रोसेसिंग के अंदर देयर आर मल्टीपल यूनिट्स भी हो सकते हैं जिसके अंदर मल्टीपल इंस्ट्रक्शंस फेच हो रही हैं। we'll talk about it in the next step. So, superscalar CPU, that is another abstraction of the CPU, another working of the CPU. There are certain CPUs which has a multiple execution unit. For example, integer arithmetic की ये execution अलग है, floating point instruction की execution के भी अलग है और boolean instruction और operations के भी execution अलग है. So the instruction can execute 3 different type of instructions simultaneously. So there could be 2 or more fetch and decode units that carry out their task and place the data in the holding buffer. यानी कि 2 fetch unit है, एक वक्त में 2 instructions fetch हो रही हैं, 2 decode units है, now 2 instructions are being decoded. Decode होने के बाद they go into the one single buffer which is called the execution buffer. अब the CPU after executing the instruction from the at any stage look into the execution buffer and picks up the next instruction which are to be executed. अब इसमें जो सबसे important और complexity है that के instruction may not execute in the order they are supposed to execute. So instruction may be executing out of their turn, out of their sequence. But now it is the responsibility of the operating system to ensure that the instructions are executed as per their position and as per they are supposed to be executed. So it is the responsibility of the operating system to ensure it, and how the operating system ensures that we'll talk about it later on. But at this stage you can see that this is the one of the requirement that has to be undertaken by the operating system. So ये जो मैंने आपको explain किया, A, the system where we have independent functional unit, जो मैंने पहली example दी थी वो यहाँ पर show नहीं हो रही. Okay, this is the second stage है जिसमें we have got a multiple separate units, जो कि as you can see that this fetch unit, so it's independently fetching the instruction. Then is our decode unit that is decoding that, and then it is an execution unit. So when the instruction n is executed, n plus 1 is decoded here and n plus 2 is fetched here. So this was a three-stage pipeline execution. In the superscalar, you can see that instead of one functional unit, we have got two functional units. This fetch, two functional units, fetch and two decoding units are there. So simultaneously multiple instructions are fetched, multiple instructions are decoded, and then they are placed into the holding buffer. And now from the holding buffer, depending upon the instructions and depending upon the execution, three execution unit, the instruction whichever is supposed to be executed, suppose एक instruction है which is waiting for to be executed here, but this is free. So the next instruction from that buffer will go there and will be executed. So it's mean that this instruction might be executed out of turn. Now it is the responsibility of the operating system to ensure that the result should be the same as per it was meant to be in the instruction set. Then they will talk about the another abstraction, the latest development in the processor. But before going to the latest, the architect, let's talk about the CPU. As we talked about the two modes of operation of the CPU, means kernel mode and the user mode. As I have already explained in my last lecture, that the kernel mode is a privileged mode, and it can execute any instruction of the instruction set. So it means it has an access to all the instructions which are available and which are present in the instruction set, and it can communicate with each and every type of hardware. Whereas a user mode is protected in the not in the term. मैंने आपसे कहा था कि वो प्रोटेक्टेड है कर्नल मोड, तो मीन्स को इससे प्रोटेक्टेड है. दिस इज जस्ट अ मैटर ऑफ एक्सप्लेनेशन कि यूजर मोड इज अ मोड हैज लॉट ऑफ रिस्ट्रिक्शंस, जबकि प्रिविलेज मोड हैज नो रिस्ट्रिक्शंस एट ऑल. तो हम ये भी कह सकते हैं कि यूजर मोड इज ए प्रोटेक्टेड मोड, प्रोटेक्टेड फ्रॉम गोइंग टू सर्टेन एरियाज, या रिस्ट्रिक्शंस हैं उनकी कुछ एरिया में जाने के लिए, to execute subset of instructions. So it does not have the privilege to execute each and every instruction, and as I already explained you that certain IO and memory protection instructions are not allowed to be executed. Now, how then the services are provided to the end user? If the end user is not allowed to execute certain instructions, then how these services will be provided? Now this is the responsibility of the operating system to provide this service. How does the operating system provide the service? For that purpose, there is a feature, a functionality which is called a system call. With the help of a system call for a service that is required by the operating system, a trap occurs. Means that whenever there is a trap, the control is transferred from the user mode to the kernel mode. So the trap instruction switches the user mode to the kernel mode. And after completing the task, the control returned back to the user to the next instruction where the trap occurred. ये ऐसे ही है कि आपका जैसे प्रोग्राम चलते चलते किसी एक जगह पे कॉन्टेक्स्ट स्विच हो गया और आपका प्रोग्राम ब्लॉक हो गया और फिर उसके बाद दोबारा से लोड हुआ और एग्जीक्यूट हुआ। जैसे ही आपने किसी प्रिविलेज्ड टास्क के लिए आपने रिक्वेस्ट की, एक ट्रैप होगा। ट्रैप का मतलब है कि योर रेस्ट ऑफ द प्रोग्राम विल बी ब्लॉक्ड and your service requested by the operating system will initiate certain procedure by the operating system. That procedure on your behalf will be executed and provide you the service. Once this service is provided and the data, for example, the service was a request for the data to be read from the keyboard or to be read from the memory. Once this data is available, then the context switch again, your block process is restarted. Now this time the block process, when it starts with the fresh data for which it was blocked before. जिस डेटा के लिए ये ब्लॉक हुआ था, अब वो डेटा अवेलेबल है, तो इसको रिस्टोर कर दिया जाएगा प्रोसेस को, और ये प्रोसेस जो है विल एग्जीक्यूट एग्जैक्टली फ्रॉम दैट पॉइंट, जिस पॉइंट के ऊपर इसने जहां पर ये ब्लॉक हुआ था। यानी कि अब डेटा इसके पास आ गया, तो प्रोग्राम काउंटर विल कंटेन द एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन, सो फ्रॉम द वेरी नेक्स्ट इंस्ट्रक्शन इट विल रिज्यूम इट्स एग्जीक्यूशन। There are some other traps, not only the user requesting for some privileged task to be carried out by the operating system result into the trap, result into the switching of the mode from the user to the kernel. While normal execution of a program, when you are executing your program and some abnormality occurs, some exceptions occur. Exception क्या है कि a user has attempted to divide a number with 0. This is called divided by 0. This is certain exception. So that quickly traps and call the operating system to interfere to that. Or there is a floating point underflow. So there is some abnormality occurs in the user program that also result in trapping to the kernel mode. क्या मतलब हुआ कि आप जब भी कोई एक्सेप्शन अकर होता है, जब भी कोई एबनॉर्मेलिटी होती है while executing a normal program into the user mode, जैसे ही एक्सेप्शन अकर होगा, ऑपरेटिंग सिस्टम जो है वो फौरी तौर पर एक्टिवेट हो जाएगा, नॉट डिपेंडिंग अपॉन के कौन सा एक्सेप्शन हुआ है, इट वाज डिवाइडेड बाय 0 एक्सेप्शन है या फ्लोटिंग पॉइंट अंडरफ्लो एक्सेप्शन है. डिपेंडिंग अपॉन द एक्सेप्शन अकर्ड, द रेलेवेंट पार्ट ऑफ द सीपीयू, द ऑपरेटिंग सिस्टम इज इन्वोक्ड and that take care of the situation that has occurred. So we still are discussing the CPUs and its functionality by the operating system. In the latest development, मैंने आपको बताया था कि number of transistors per unit area are increasing, keep on increasing. So obviously that has resulted in the advancement. So the multi-threaded or hyper-threaded CPUs have been launched. Means that they are replicate not only functionality unit but also the control logic. इससे पहले हमने जो चीजें डिस्कस की कि हमने कहा कि मल्टीपल फंक्शनैलिटी कंपोनेंट्स हैं, जैसे फेच कंपोनेंट्स आपके पास मल्टीपल हैं, डिकोड कंपोनेंट्स आपके पास मल्टीपल हैं, बट वी यूज टू ऐड वन सिंगल एग्जीक्यूशन यूनिट. व्हाट हैपेंस इफ यू हैव और रेप्लिका ऑफ दिस एग्जीक्यूशन यूनिट्स जो हैं वो भी मल्टीपल हो गए. लॉजिकली आपके पास ये कह सकते हैं सीपीयू भी एक से ज्यादा हो गई है. So when you have the control logic means CPU, this means that you allow to hold two different threads and then switch back within the nanosecond. अब आपके पास प्रोसेस तो एक है, हम कॉन्टेक्स्ट स्विचिंग नहीं कर रहे. कॉन्टेक्स्ट स्विचिंग में होता है कि सीपीयू इज स्विच्ड बिटवीन वन प्रोसेस टू द अदर प्रोसेस. एक प्रोसेस से दूसरे प्रोसेस में जाता है, एक जॉब से दूसरे जॉब में जाता है, एक यूजर से दूसरे यूजर में जाता है. लेकिन इस पर्टिकुलर सिनेरियो के अंदर व्हेन वी हैव अ मल्टीपल सीपीयूज, तो अब मल्टीपल प्रोसेसेस पे जाने की जरूरत नहीं है. यू आर एट वन टाइम यू आर हैंडलिंग वन पर्टिकुलर प्रोसेस. सो विद इन द प्रोसेस यू माइट हैव अ मल्टीपल पैरेलल एक्टिविटीज that might have been requested by the end user, और इसको कहते हैं thread. If there is a parallelism in the process which is called thread, so in the shortcut we can say that the threads are the lightweight processes. I'll explain it later on कि जो thread है इसका एक hardware abstraction है और एक इसकी software abstraction है. I'll explain it in the next slide. So multi-threading has implication for the operating system. Each thread appears to operating system as if a separate CPU. अब complexity बढ़ गई, CPU ने ये भी देखना, operating system ने देखना है कि there are multiple CPUs and it has to give the task, assign the task to the multiple CPUs and pick up the result from the multiple CPUs and still ensure the end user that the program has been executed according to the sequence and according to the instructions given or logic provided within the program. So the system with two actual CPUs, and suppose there are एक ऐसी environment है, एक ऐसा computer है where we have got दो CPU हैं और हर CPU के अंदर there are two threads. ये physical threads हैं, means physical execution units हैं उसके अंदर. With two threads and two CPUs, operating system के लिए there are 4 independent CPUs available within the single computer. And operating system now need to manage these 4 CPUs for different tasks. I said that there are two abstractions. जो physical thread है means the physical duplication है hardware की, this is called an hardware abstraction. अब एक process के अंदर एक capability है, process के अंदर parallelism की capability है, and so that कि एक task के अंदर there could be two process, two sub instruction that could be executed in parallel. तो ये parallelism की, ये जो multi-threaded की abstraction है in terms of software है. So a thread could be a hardware abstraction or thread could be a software abstraction. अगर ये हार्डवेयर एब्स्ट्रैक्शन है तो आप समझेंगे दो डुप्लीकेट सीपीयूज हैं, और अगर ये सॉफ्टवेयर एब्स्ट्रैक्शन है तो इसका मतलब है कि एक पर्टिकुलर प्रोसेस के दो एग्जीक्यूशन की रिक्वेस्ट साइमल्टेनियसली पैरेलल एम्बेडेड है आपके प्रोग्राम के अंदर, आपकी इंस्ट्रक्शंस में. ओके, we have seen the abstraction of the CPU. The next physical device is called the memory. We need to see the memory because we have got a variety of memory. There's something that has been all the time available with all of its diversity. For example, we have a very, very fast storage memory which is built up with the material as good as the material of the CPU. So this storage is within the CPU. They are very fast. And they can execute instruction in the less than nanosecond. ये वही speed है जिस speed के साथ आपका CPU execute करता है, उसी speed से data को access कर लेता है. But the size of the registers is less than 1 kilobit. What does it mean? If we are talking about a 32-bit architecture or 32-bit machine, then we have a 32 registers each of 32-bit. But if we are talking about a 62-bit architecture, then we have 64 registers each of 64-bit. But अगर इनको देखा जाए तो इसका size अगर 32 क्या होता है? 2 raised to power 5. 2 raised to power 5 multiplied by 2 raised to power 5 bits. So 2 raised to power k bits. जब हम bits की बात करते हैं, it is less than byte, so it is less than 1 kilobytes. And 64 क्या है? 2 raised to power 6. So 2 raised to power 6 multiplied by 2 raised to power 6 is 4k bits. 8k bits जो है, that is equal to 1 kilobyte. So even 4k bit is less than 1k. So your registers जो हैं, they are very limited and smaller in size, very expensive because they are within the CPU, and that's why they have a very small in size. Then comes the cache. Cache is the storage unit that is available within the chip, within the CPU. Now we have within the CPU two types of cache, or rather more types of cache that I will explain it later on. But this is the storage which is available. If it is an L1 cache, its size is 64K. If it is L2 cache, its size is around 4 MB, or maybe nowadays we have got 8 MB or 16 MB cache. Level 2 or level 3 is available. Then comes the main memory. Main memory is the memory of the computer, that is called RAM. I will explain you later on, but this is a random access memory, very fast than the hard disk, but very slow as compared to the registers and cache. Then much slower, 10 times slower than the, rather many times slower from the memory is the hard disk, because hard disk comprises electromechanical component. It has got mechanical part, it has got electrical part, so that's why the hard disks are usually very slow, but have the larger size, number of times, multiple orders of the time of the size of the main memory. And finally, magnetic tapes, although they are very rarely used, but still they are very useful because they are in a very huge size, very large size, and very, very cheap, and they are used for certain purposes, mostly the backup and some other. I'll explain you later on. So if we talk about the hierarchy of this hardware, that is the memory, so it starts from the register, then cache, then the main memory, then the hard disk, then the magnetic tape, and the topmost is very fast but very expensive. The lowest one are very cheap and very large but very, very slow. So the numbers are very rough approximation. थोड़ी सी मैंने कैलकुलेशन आपको इनकी रजिस्टर्स की करके दिखाई थी, but in order to just present it here in the form of one slide, we have to have certain approximations. So we have talked about the registers. Let's talk about the cache. So main memory is divided into the cache line. This is the storage which is available within the CPU. It is organized in the form of 64 bytes. So for each block we have an address line. For byte number 0 to 63 we have the first line, and for byte number 64 to 127 we have the second line. But in terms of address की अगर हम बात करें तो 0 to 63 is available on line number 0 and 64 to 27 is available at line number 1. Book में you might find it out as line 0 and line 1, but basically it's a relative term. If अगर हम 0 को 1 कहें, मतलब first कहें, और 1 को second कहें, तो it could be 1 and 2, or it could be 0 or 1. So basically these are the address lines which identify which block you are going to access. यानी कि कैश के किस ब्लॉक को आपने एक्सेस करना है. Each block is of the size of 64 bytes. So 64 bytes का जो आपका ब्लॉक है, 64 bytes multiplied by 8 is basically 2 raised to the power 6 and 2 raised to the power 3 is 2 raised to the power 9, which is 512 bit का एक आपका ब्लॉक है. So when the program reads a word, जब कोई word चाहिए होता है किसी भी instruction को, when any instruction refers to any address, it just try to find it out कि this address is required. So first of all, that word is located into the cache. If that word is available into the cache, then it is called a cache hit. इसका मतलब है कि that word could be retrieved within 2 cycles, within 2 machine cycles या 2 clock cycle के अंदर वो आपको मिल जाएगा. But if it is a miss, then it's a long story. Then you have to wait, because now you are required to transfer it from the physical memory of the computer, and you will bring it back into the cache, and then you will hand it over to the CPU registers for the execution. So ideally we need to put everything into the cache, but since the size is very limited and it's very expensive, so you cannot put in everything into the cache. So cache is expensive and therefore limited in size. So we can have even the cache hierarchy. We can have a cache of level 1, we can have a cache of level 2, we can have a cache of level 3. Cache of level 1 जो है, that is अराउंड 16K की कैश है, that is within the CPU आपके पास available है. It is called level 1 cache. It is very fast, just like almost equal to the size of the registers and very fast. But the level 2 is the storage unit that has again within the CPU, but obviously it is need some access mechanism, and it is slightly slower than the level 1 cache. Then we also have a level 2 cache, level 3 cache. So the cache can keep on the information. Anything that is required, you can put it into the cache. Students, cache is basically a concept also. ये ऐसा नहीं है कि सिर्फ CPU के अंदर जो हमने स्टोरेज दी है उसी को कैश कहते हैं. फॉर एग्जाम्पल, एक फाइल जो है, यू वॉन्ट टू रेफर टू वन पर्टिकुलर फाइल एंड यू वॉन्ट टू हैव दैट फाइल इनटू द मेमोरी ऑफ द कंप्यूटर. सो व्हाट यू कैन डू कि इफ द फाइल इज नॉट अवेलेबल इन द मेमोरी ऑफ द कंप्यूटर, देन यू हैव टू रीड इट फ्रॉम द डिस्क. वही कॉन्सेप्ट है. अब डिस्क इज एन इलेक्ट्रोमैकेनिकल डिवाइस. अब डिस्क से मेमोरी आने में इट विल टेक मच टाइम. तो वही कॉन्सेप्ट है. यू वांट टू कीप द मोस्ट रेफर्ड पार्ट ऑफ द डेटा टू a place which is conveniently and relatively much faster to handle. अब मेमोरी में इंस्ट्रक्शंस रखनी और सीपीयू के अंदर इंस्ट्रक्शंस रखनी में यू विल प्रेफर टू कीप इट इनटू द विद इन द सीपीयू, ताकि आपकी इंस्ट्रक्शन क्विकली अवेलेबल हो. उसको हम कैश पे रखते हैं. फिर अगर फाइल की बात करें और डेटा की बात करें इन द मेमोरी, तो यू विल प्रेफर टू कीप द फाइल, वो फाइल का पोर्शन विच इज मोर फ्रीक्वेंटली रेफर्ड, आप चाहेंगे कि वो मेमोरी में रहे, और जो रेस्ट रेफर्ड पार्ट है आपकी फाइल का वो हार्ड डिस्क के ऊपर रहे. तो कॉन्सेप्ट कैश का वहां पर भी मौजूद है. कॉन्सेप्ट कैश का टॉप लेवल के ऊपर भी मौजूद है. So there are certain questions. ये मैंने इसलिए एक्सप्लेन किया कि now these 4 questions are valid for the concept. ये CPU के लिए भी वैलिड है, ये मेमोरी और हार्ड डिस्क के लिए भी वैलिड है, मेमोरी और CPU के लिए भी वैलिड है, और फर्दर भी आप इसको एक्सटेंड कर सकते हैं. So first question is when to put a new item into the cache. Obviously, when there is a need, when there is a requirement of the data, quickly take the decision whether you will put it into the cache. अगर वो इंस्ट्रक्शंस से रिलेटेड है तो क्या कंप्लीट सेट ऑफ इंस्ट्रक्शंस जो पूरे का पूरा ब्लॉक है उसको कैश के में ले जाया जाए, और अगर फाइल है तो क्या उस फाइल के उस पोर्शन को मेमोरी में लेके जाया जाए. सो ऑब्वियसली ऑन ए कैश मिस you have to take the decision whether to put a new item into the cache. Which cache you want to put the new item in? अब उसको कहाँ पे रखा जाए? That is another question. Obviously, when you want to put certain item somewhere into the area which is a very sensitive or very small in size, so then it's mean that you have to locate, you have to make the space over there. आपको वहाँ जगह बनानी पड़ेगी, उसके लिए आपको कोई item remove करना पड़ेगा. So the next question is which item to remove from the cache? When a slot is needed, you have to take certain item out of that. तो अब आप ऐसा ना हो कि जिस आइटम को आप आउट ऑफ कैश कर रहे हैं, कैश से बाहर भी जा रहे हैं, फौरी तौर पर नेक्स्ट मशीन साइकिल में उसी की जरूरत पड़ जाए. So you have to be a bit intelligent, and there are a number of algorithms that we will study later on that will decide which item to take out and which item to put in. Finally, where to put newly evicted item in the main memory. ये भी एक है कि जिसको आप निकाल रहे हैं उसको किस जगह पर लेकर जाना है. Because there are certain calculations, there are certain activities. एड्रेस रेजोल्यूशन है, एड्रेस को कैलकुलेट करना है, कंप्यूट करना है, फिर उसको आइडेंटिफाई करना है. सो यू हैव टू टेक सर्टेन डिसीजंस एट सर्टेन टाइम. लिहाजा जिस चीज़ को आप कैश आउट कर रहे हैं, आप उसको सीपीयू से मेमोरी में भी जा रहे हैं या मेमोरी से हार्ड डिस्क में भी जा रहे हैं, देन अगेन यू हैव रिक्वायर्ड टू टेक अ सर्टेन डिसीजन कि आपने उसको आउट करके कहाँ भी जाना है। देयर आर मल्टी कोर चिप्स ऑल्सो, क्योंकि वी आर टॉकिंग अबाउट द कैश, सो देयर वाज अ concept that I talked about when I said the CPU abstraction की जब मैंने बात की थी, तो हमने पहले ऑर्डिनरी चिप्स की बात की थी, फिर हमने पाइपलाइन की बात की, then we talked about the superscalar, and now I say that multi-core are basically multiple CPUs. अब हमने स्ट्रेट फॉरवर्ड कह दिया है मल्टीपल CPUs, यानी कि multiple CPUs could be put into the computer as an advancement. Each CPU is supposed to have its own cache, which is called L1 cache. Now there is another concept. I said there is a hierarchy of cache also. We can have level 2 cache. Now Intel has introduced a concept where level 2 cache is shared among multiple cores, mean multiple CPU chip. These are all 4 CPUs on a single chip. So these 4 CPU can share the level 2 core. And this is the concept which has been introduced by the Intel. But AMD ने क्या किया? There is a competitor of Intel which is AMD, and AMD said that even level 2 cache could also be within that particular core. यानी कि उसी जहां पर आपका CPU है उसी के अंदर अगर आप उसको प्लेस कर दें. So both have their merits and demerits and their advantages and disadvantages. So a quad core chip with a shared L2 cache, quad कहते हैं 4 को. So this is a quad core processor, means it has got 4 CPU, each having its cache either shared. In the case of A it is shared, and as I said it is the example of Intel, and in case B it is separate, and this is an example of AMD. So CPU have a multi-core chip, so CPU chip with 2, 4 or more multi-processor or multi-core on them are commonly available. Okay, this multi-core or multi-threading or hyper-threading are different. Okay, and I hope कि अब आपको समझ में आ गया. Multi-threading कहते हैं कि एक कोर की capability of carrying out multiple execution at the same time with redundant threads available within that, multi-threads available, hyper-threads available, but one CPU. और अगर CPU ही अगर आप repeat कर दें एक chip के अंदर, then it is called multi-core chips. So the next is in the hierarchy is the main memory. The main memory of the computer initially इसको हम कहते थे core memory, क्योंकि उस ज़माने में core से होती थी, उसका एक concept था अपना. But now it is called a RAM, random access memory. You can access anywhere, any block of memory at any time. You are not supposed to go in a certain sequence. This is called a volatile. Volatile means it is sensitive to power. As long as the power is there, the data whichever is available in the memory retains there, but whenever the power is switched off, the data is vanished, and that's why it is called volatile. And it has of the order of gigabytes. So we can have 1 gigabyte RAM, very common with PCs, and we can have 8 gigabytes available with the workstations, and nowadays the servers which are available have 32 gigabytes of the RAM which are provided. It's very fast as compared to the hard disk, as I've already explained it. Next is a ROM. This is like RAM, but it is limited in size. And it has an advantage over RAM that it is non-volatile. It means that whatever information is available in the ROM can be retained even if no power is there. So basically the information permanently stored on a chip is called ROM. और जो information है जिस chip में उसको store करते हैं उसे ROM कहते हैं, और जो information होती है उसको हम कहते हैं firmware. हमने बात की हार्डवेयर की, हमने बात की सॉफ्टवेयर की. देयर इज अ न्यू कॉन्सेप्ट व्हिच इज कॉल्ड फर्मवेयर. फर्मवेयर कहते हैं इंफॉर्मेशन परमानेंटली स्टोर्ड ऑन अ चिप इज कॉल्ड फर्मवेयर. उसके लिए बेसिकली हम ROM को यूज करते हैं रीड ओनली मेमोरी। रीड ओनली मेमोरी का मतलब है यू कैन जस्ट कीप ऑन रीडिंग एंड एक्सट्रैक्टिंग द इंफॉर्मेशन, यू कैन नॉट राइट इट। ऑब्वियसली ओनली द मैन्युफैक्चरर जो है वो वन टाइम उसको राइट करके भेजता है और उसके बाद आप उसको रीराइट नहीं कर सकते। It has limited in size, and that's why sometimes the bootstraps operating system loaders or device controller for IO cards जो है उसके जो controllers हैं वो ROM के अंदर provide किए जाते हैं। Similar to the ROM, there is another type of memory which is called EEPROM. इससे पहले एक और भी आई थी जिसको हम कहते थे EEPROM, erasable programmable read only memory। लेकिन वो जो अरेज होती थी वो अल्ट्रा वायलेट बॉक्स में रख के फिजिकली वी वर सपोज टू टेक द चिप आउट, हम उसको चिप को निकालते थे, एक बॉक्स में रखते थे, उसमें अल्ट्रा वायलेट लाइट होती थी, एक विंडो होती थी उसके ऊपर चिप के ऊपर, उससे लाइट उसके अंदर जाती थी और डेटा को अरेज करते थे। That has been observated with the invention of EEPROM। EEPROM है electrically erasable। electrically erasable का मतलब है कि जहां पे ये लगी हुई है वहीं पे इसको निकालने की जरूरत नहीं है, जहां जिस जगह पे लगी हुई है वहां लगे लगे while it is installed over there you can just refresh it, you can delete the previous data and you can rewrite that, but certainly it has a limitation and you can write quite a few times on that, but it has a certain number, after that you cannot write it on that, but it is quite sufficient. So basically it is again non-volatile, means it doesn't require power to retain the information, so you can also erase and rewrite that, so you can place certain information or you can pass it on to the end user by putting that information into the EEPROM, and the user can time to time update this information जब भी उसकी रिक्वायरमेंट आए, जब भी उसको जरूरत हो, कैन डू दैट। और इसको हम फ्लैश मेमोरी के तौर पर भी यूज करते हैं। वी यूज EEPROM एज ए फ्लैश मेमोरी, जो आपकी USB ड्राइव है, डिवाइस है। It is used as a storage media for portable electronic devices. फॉर एग्जाम्पल ये काम करती है एक फिल्म का अगर कैमरे के अंदर हो, पहले कैमरे में फिल्म डलती थी, अब कैमरे में आप USB डिवाइस USB स्टिक लगा सकते हैं और वो वही काम करती है। मीन्स यू कैन जस्ट कीप ऑन टेकिंग द स्नैप्स एंड यू कैन स्टोर इट इनटू द USB, और यू कैन टेक a USB as a portable hard disk also to take your data from one place to other place. There is another type of RAM that is storage that is available, which is called CMOS. It's a volatile, but it is a low power consumption. Low power consumption का मतलब क्या हुआ कि it consumes a very little power. That's why अगर manufacturer ने आपको CMOS दिया, उसके साथ usually provides a battery, and with the help of that particular battery, the information retains there for quite some time. Sometime ऐसा होता है कि उसकी lifetime तक भी information is retained there. Then come disk. Compared to RAM, it's an electromechanical device. It's a much higher capacity as compared to the RAMs. We have multiple plates, and on plates there is an arm that moves inside and outside. So on each plate there is a concentric circle, and this concentric circle is called a track. And then all the track on one position, so that the simultaneously all the head can read and write the same track number on each and every surface of the hard disk, is called one cylinder. It can rotate the plate at a different speed, at a speed of 5400 RPM or 7200 RPM, and the very latest hard disks are available that can execute at the speed of 10,800 RPM. So basically it is also very complex like floppy disk, because you have multiple plates, and it has got more complexity because on each track there are certain data which is recorded into the form of semicircle, which is called a sector. Usually one sector comprises 512 bytes. The packing density remains the same, but nowadays the outer tracks have got more sectors as compared to the inner tracks. Packing density ज़्यादा होने की वजह से outer track जिसका size बड़ा होता है has got more sector as compared to the inner track. So the complexity for the operating system is much higher. The seek time कहते हैं to extract the information from the hard disk. I'll quickly explain that in a minute or so. If you want to extract the data from the hard disk, you need to go through 4 steps. And after going through these 4 steps, you read or write the data. These 4 steps का जो total time है, it is called the seek time. First of all, arm positioning time. Arm positioning means that you have to move the arm forward and backward so that it could be placed into the proper position, proper cylinder position where you can read and write the data. Usually it requires 1 millisecond to move the head from one cylinder to the next cylinder. On average, you require 5 to 10 milliseconds to position the arm within the required. It's obviously relative movement. That's why the time is much less as compared to the 1 millisecond. But obviously, there are usually 200 tracks, 200 cylinders. So yet the time is of the order of 5 to 10 milliseconds. Then comes rotational delay. Once the arm is positioned to the proper position, then it takes certain time to rotate the sector and comes under the read-write head. वो rotate करके read-write head के नीचे आएगा, इसको कहते हैं rotational delay. And once again, this is of the order of 5 to 10 milliseconds. Then the data transfer time. The data transfer time is also much slower because you can read in the older hard disk, you could able to read 50 megabytes per second की speed से, and then we have now 160 megabytes per second. So depending upon the hard disk, it varies in size, the transfer rate. And then the actual time of reading and writing the data, that also constitute towards the total time computation. So the seek time basically is all the combination of these steps. So the concept of virtual memory, memory management unit, context switching, and all these are related. This memory management unit is usually the part of the अगर आपने देखा होगा एक ड्राइंग मैंने दिखाई थी फिगर आपको, the simplest version in the beginning of the lecture that has MMU means a memory management unit which takes up certain responsibility of transferring the data from disk to the memory and memory to the disk, and we could save certain time with the help from that. So there is also a term which is called context switching. मैंने थोड़ा सा इसको टच तो किया है कि जब आप एक प्रोसेस से सीपीयू लेके दूसरे को असाइन करते हैं, इसको हम context switching कहते हैं, and I'll come back to it in the later chapters also. So before I conclude, next device भी हम देख लेते हैं क्योंकि which are the tapes are very economical and we used to transfer the data, we used to take up the backup purposes, and their size is very large, but we can save the data onto the tapes and we can store it somewhere outside the our data centers, so that कि अगर खुदा न खास्ता if there is any force majeure or if there is something, then still you can recover the data from some other location. So portability or with a large size is very convenient. So we first need to mount the physical spool. उसको जो tape होता है उसको spool कहते हैं. उसको first of all we just require to make the part of this system. तो उसके भी उसको आपको माउंट करना होता है, and then you just read the data or write the data back onto the tapes. So अगर जरूरत टाइम मिला तो I will just would like to explain it later on. Then comes I/O devices, but I think I will take up these I/O devices in the next lecture because I think I have covered quite a good number of devices today, and also we are the start of our course. So I don't want to put too much pressure on you to go through it and read it out. लेकिन एक बात का ख्याल रखिएगा कि मैंने आपसे कहा है कि अगर शुरू के चैप्टर में स्टार्ट में अगर कोई चीज़ आपकी समझ में नहीं आती तो बिल्कुल घबराने की, डरने की कोई बात नहीं है। हम ये सारी चीज़ें बार बार पढ़ेंगे, बहुत डिटेल से पढ़ेंगे। मैं आपको क्वेश्चन कर दूंगा कि दिस इज द लास्ट टाइम वी हैव डिस्कस्ड दैट पर्टिकुलर कॉन्सेप्ट, ओके। लेकिन जैसे मैंने आपको शुरू में कहा, इन द फर्स्ट चैप्टर all the concepts that we will be discussing is just the introduction, and it has got a lot of technicalities, so you might not be able to digest 100%. Okay, with that we conclude today's lecture. Till next lecture, Khuda Hafiz, Allah Nigeban.